students. In the previous classes, we have started with the type study of Cycas. In the last class, we have discussed about the virgin distribution and even the external morphology of Cycas. So, in today's class, we will discuss about the anatomy of root in detail. So, in the previous class, I have told you while explaining the external morphology of roots, the roots system in case of Cycas, it mainly consists of two types of roots. One is the normal taproot system, which helps in encourage and also it helps in absorption of nutrients and even the water. So, taproot system. This is the main function of normal taproot system, which is present in Cycas. And another special type of root system, which is present in Cycas, is known as Coralloid roots. These Coralloid roots are apogeotropic and they are negatively geotropic in nature, which are present on the surface of the soil, or they are developed from the normal taproot system. Usually, they are developed on the surface of the soil. Why these are known as Coralloid roots means they appear, the mass of the root, it appears like the corals which are present in the sea. So, they are known as Coralloid roots. These Coralloid roots, they mainly consist of algae and they show symbiotic association with algae like nostoc and anaconda. These nostoc and anaconda, they mainly help in nitrogen fixation. So, this is about the Coralloid roots. The main function of this Coralloid roots is they help in nitrogen fixation. These are the two types of roots which are present in Cycas, normal taproot system and the Coralloid root system. So, in today's class, we will see the anatomy or the internal morphology of internal structure of these roots. First one, let us see the internal structure of a normal young root. If you take the section of the normal root and if you observe it under the microscope, it exactly looks like this, the transverse section of normal root. While studying the normal root system, the section of normal root system, it is mainly divided into three regions. The outermost layer is epiderma and it is followed by a large cortex, and the central part of this section consists of the stem or the vascular bundle system, vasculature. It is commonly known as stem. The central part which consists of vascular bundle, it is known as stem. So, let us see one by one. The outermost layer of this root is epiderma. This epiderma mainly consists of single layer compactly arranged cells. Epiderma is the outermost layer. It is consists of single layer compactly arranged cells. Above the epiderma, you will see the presence of cuticle. This cuticle, it mainly helps in protection, and another important function of this cuticle is it helps in preventing the excessive water loss. So, the outermost layer is epiderma. Epiderma is covered by cuticle. They both help in protection, and some of the cells in epiderma, they protrude out of the cuticle and they act as root hairs, or some of the cells in the epiderma, they protrude outside and they develop into root hairs. The main function of these root hairs is they help in absorption of both water and minerals. Some of the epidermal cells, they protrude outwards and they develop into root hairs. absorption of water and minerals. So this is about the outer layer of root. Mainly constitute root hairs, cuticle and epidermis. This is the outermost layer of root. This epidermis is followed by a large cortex. So this part is nothing but the cortex. And again this cortex is made up of loosely arranged polygonal cells. Loosely arranged polygonal cells. And some of the cells in the cortex, they show accumulation of tannins. For example, you can see here in one of the cortical cell, it has accumulated tannins in it. So the main function of this tannin is nothing but the protection. It helps in protection of the root. This tannin is nothing but a phenolic compound. It's a phenolic compound. Phenolic compound. These phenolic compound, they help in protection. How they help in protection means whenever a bacteria, fungi or any parasite attacks this particular root, these phenolic compounds, they help in or they resist the attack of bacteria or fungus. So they help in protection of root. Cortex, some of the cells in the cortex, it consists of tannins. These tannins are nothing but the phenolic compounds. These phenolic compounds help in protection. They help in getting resistance from the attack of bacteria and fungi. And some other cells in the corticals, they show deposition of calcium oxalate crystals. Calcium oxalate crystals. These calcium oxalate crystals, which are present in the cortical cells, they are having star shape. These star shaped calcium oxalate crystals are nothing but the spherophytes. They are commonly known as spherophytes. These are nothing but the calcium oxalate crystals which are deposited in the cortical cells. Again, the main function of these spherophytes is protection. These spherophytes, they mainly help in protection. And some of the cells, they also show the deposition of starch. Some of the cortical cells, they show the deposition of starch. Starch is stored in some of these cells, and this starch, it acts as a reserve material. So this is about the cortical region. So the cortical region is mainly made up of loosely arranged polygonal shaped cells, and some of the cells in the cortex, they show deposition of tannin. So they are commonly known as tannin cells. These tannins are nothing but the phenolic compounds. These help in protection, and these phenolic compounds, they mainly help in providing resistance against the pathogens like bacteria and fungi. And some more cells, they show deposition of calcium oxalate crystals. So star shaped calcium oxalate crystals are present in the cortex of root. They are known as spherophytes. Again, the main function of these spherophytes is protection. And some more cells, they show deposition of starch granules. These starch granules, they act as the reserve food material. So this is about the cortical region. Next, coming to the important part of the section of root. The central part, which consists of vascular bundle, is commonly known as steep. The central part is steep. This steep consists of endodermis, pericycle, and the vascular bundles. The outermost layer of this steel is known as the endodermis, and this endodermis is made up of a single layered, compactly arranged cells. This is the outermost layer of the stem. This endodermis is followed by 2 to 3 layers of pericycle. This endodermis and pericycle, they help in protection. Again, they help in protecting these vascular bundles. And at the center of the stem, you will find the presence of vascular bundles. While explaining the general characteristics of gymnosperms, I told you these gymnosperms, they consist of well-developed xylem and phloem. But in case of xylem, xylem results are absent, and in case of phloem, companion cells are absent. So, if you look at the structure of xylem and phloem, usually the xylem here in case of Cycas, it is said to be exact in nature. Xylem is exact, and it is also said to be dia. This P is dia, or the arrangement of vascular bundles is dia. So this dia is nothing but di means 2. You know that di means 2. Usually the vascular bundles that they are present in 2 in numbers. So 2 vascular bundles are present. Di means 2. So here 2 xylem elements are present. 1 set of xylem elements, 2 xylem elements and 2 phloem. So di means 2. Dia means the presence of 2 stripes of xylem and phloem. And exact means usually the first form of xylem is known as protoxylem. Protoxylem is first form, and the later form of xylem is known as the metaxylem. It is later form. First form is protoxylem. Proto means first form of xylem. So this exact means usually this protoxylem, it is present towards the periphery, or it is present towards the pericycle. Periphery. In case of exact condition, the protoxylem is present towards the periphery, and the metaxylem is present towards the center. So this condition is known as exact. When you say exact, xylem is exact, at that time usually the protoxylem is present towards the periphery and the metaxylem is present towards the center. So this condition is known as exact. So usually in case of normal roots, the stem is said to be dia. Dia means 2 stripes of xylem and phloem are present, and the xylem is usually exact in nature. Exact means protoxylem is towards the periphery and the metaxylem is towards the center. And in between these 2 stripes of xylem, phloem is present. Phloem strands are present on both the sides. Phloem strands are present. So this is about the stellar region in case of normal root. And usually in case of Cycas, the root shows secondary growth. The root shows, this is normally here I am not showing the secondary growth, but in case of Cycas root it shows secondary growth. Secondary growth is nothing but the increase in the girth or the thickness of root. If it is occurring in the stem, it is nothing but the increase in the girth of the stem. If it occurs in the root, it is said to be increase in the diameter of the girth of the root. So how it increases the girth of the root means, here in case of cortical region, cork cambium is present, and in case of stellar region, vascular cambium is present. So this cork cambium and vascular cambium, they divide continuously, and in the cortical region they produce phloem and phloderm. In the vascular region, the vascular cambium it gives rise to secondary phloem and secondary xylem. Because of the formation of phloem, phloem and the phloder, and even because of the formation of secondary xylem and secondary phloem, the girth of the root increases. So this process is known as the secondary growth. Secondary growth mainly occurs because of the activity of carp cambium and vascular cambium. So this is about the anatomy of normal root system. Next, coming to the anatomy of the special root, that is coralloid roots. See, the main difference between the anatomy of normal root and the coralloid roots, it lies in the article region. If you look at the anatomy of coralloid roots, the outermost layer of this coralloid roots is known as periderm. Why it is known as periderm means after the secondary growth in the cortical region, the carp cambium will divide. Towards the outer side, it produces phloem. Carp cambium. In the cortical region, carp cambium is produced. This carp cambium towards the outer side, it produces phloem, and towards the inner side, it produces phloder. These three together called as periderm. Phloem, carp and phloder, they together called as periderm. Because of the extensive division of these cells of the periderm, the epiplemma and the cuticle is disappeared in case of coralloid roots. So the outermost layer of this coralloid root mainly consists of periderm. Periderm is nothing but phloem, carp cambium and the phloder, they together called as the periderm. And if you look at the cortical region of coralloid roots, the cortex in case of coralloid roots, it is differentiated into three parts. The outermost region of the cortex is known as the outer cortex. This outer cortex, it consists of compactly arranged polygonal shaped cells. The outer cortex, it mainly consists of compactly arranged polygonal cells. And after the outer cortex, you will find the middle cortex. This middle cortex is also known as algal zone. This middle cortex, it is mainly made up of a single layered elongated cells. And inside these elongated cells, you will find the presence of algae like nostoc and anabaena. Inside the middle cortex is made up of long elongated single layered cells. This middle cortex is also known as algal zone because of the presence of algae like nostoc and anabaena. In the middle cortex, nostoc and anabaena are present, and these two algae, they mainly help in nitrogen fixation. Next, after the middle cortex, the innermost part of the cortex is known as the inner cortex. And this inner cortex, it is made up of loosely arranged cells, and this inner cortex, it consists of some of the specialized cells like starch containing cells, tannin cells and spirophyte cells. These three cells, they are also present in the inner cortex of coralloid roots. And the main function of those special cells is they help in protection, particularly tannin cells and spirophyte cells, they help in protection, and the starch containing cells, they help in these starch is nothing but the storage food material. So this is about the cortical region or the cortex in case of coralloid roots. It is differentiated into three parts. Outermost one is made up of compactly arranged polygonal cells, which is known as outer cortex. Outer cortex is followed by the middle cortex. Middle cortex is made up of single layered elongated cells. This middle cortex is also known as algal zone because of the presence of algae like nostoc and anabaena. It is followed by the inner cortex. The inner cortex is made up of loosely arranged cells. These cells, some of the cells in the inner cortex, they show deposition of tannins, calcium oxalate crystals, and starch granules. Next coming to the stellar part of the coralloid roots. Again, if you look at the stellar parts, the outermost layer of the stele is known as endodermis. Endodermis is made up of a single layered compactly arranged cells. It is followed by 2 to 3 layer pericycle. And the central part is nothing but the presence of vascular bundles. Again, here in this case, in case of coralloid roots, the stele is triarch in nature. Triarch means, tri means 3. Here the vascular bundles, they are present 3 in numbers. Usually 3 xylem are present and 3 phloem bundles are present. In case of normal roots, it is said to be diarch. Diarch means the xylem and phloem, they are 2 in number. But here in case of coralloid roots, the stele is said to be triarch in nature. Triarch means the xylem and phloem, they are 3 in number. Again, the xylem is said to be exarch. Why it is exarch means the metaxylem is present towards the center and the protoxylem is present towards the periphery. So the xylem is said to be exarch and the stele is triarch. And each xylem alternatively consists of phloem. The phloem is present in alternative position with the xylem layers. So this is about the stellar region of coralloid roots, and this is about the anatomy of normal and the coralloid roots. The main difference between the normal and the coralloid roots is, the main difference lies in the cortical region. The normal roots, only a single type of cortical cells are present, but in case of coralloid roots, the cortex is differentiated into 3 regions: outer cortex, middle cortex, and the inner cortex. To come to the stellar part, the stele is diarch in case of normal roots, and in case of coralloid roots, the stele is triarch in nature. So this is about the anatomy of normal root and the coralloid roots. In the next class, we will discuss about the anatomy of stem.